begin with a mini silent in memory of Herbert. Please stand up. I give immediately the word to Esther Rose because her health situation is not ideal and he has to go away as soon as possible.
Ich spreche nicht Englisch,
Wie du willst, Esther.
Gut, ich spreche Deutsch, weil die meisten verstehen. Ich bin sehr erfreut und auch berührt, dass ihr wiedergekommen seid, nach 30 Jahren, nach Herberts Tod zu diesem Treffen. Und ich bin auch sehr erfreut, dass ihr immer noch Freude habt und Lust in dieses schwierige Gebiet, das Herbert eröffnet hat, wiederum einzutauchen und dass ihr ja schon eingetaucht seid, ganz am Anfang mit der Dissertation. Ich danke euch, dass ihr gekommen seid. Ein ganz großer Dank geht an Herrn Remo, der schon vor einem Jahr begonnen hat mit den Vorbereitungen und der keine Mühe gescheut hat, um dieses Treffen möglich zu machen. Es war diesmal nicht einfach, weil all die Sponsoren waren nicht mehr gewillt, wie früher Geld freizumachen. So ein Mathematiker-Treffen. Die haben alle das Gespenst der Krise vor Augen. Ich danke auch. Aber Remo hat es möglich gemacht. Ich danke auch Autor, der auch noch geholfen hat am Schluss mit der Realisierung der Atti bei technischen Problemen. Und ich danke Suzu, der sofort gesagt hat zu mir, weil er weiß, wie wichtig mir meine Vergangenheit ist und wie sehr ich mich auf das Treffen mit euch gefreut habe. Er wolle es filmen. Schauen wir dann, wie es herauskommt. Er hat ein bisschen eine komplizierte Apparatur. Was mich anbelangt, ich hätte euch sehr gerne wieder eingeladen zu uns und hätte mich sehr gefreut, wieder zu kochen, so wie das die Tradition ist. Aber es geht diesmal nicht, weil es mir einfach nicht möglich wäre, so lange in der Küche zu stehen, nach dieser misslungenen Operation. Jetzt wünsche ich euch eine spannende Reise in die verschiedenen Gebiete eurer Vorträge und freue mich, euch heute Abend und morgen Mittag wiederzusehen. Ich hoffe sehr, dass ihr möglichst alle morgen Mittag dabei seid.
Prepare that. Well, we dedicate this article to Herbert I remember Herbert as a very beautiful person, nice person, and well, we dedicated her that. Well, first, ¿cómo se quita eso?
Haciendo frita.
Ah.
En el lado.
Some definitions. Let A and B on a little lattice, a little space, over a division ranks K with automorphismal bar. In K there are two subgroups, S and T. S is whose elementals are symmetrics, and T given by a trace. And in E, we consider a subspace given by a trace, B and E, such that phi BB is in T. This is very special subspace. It has many properties. For example, for all space F, the radical of F is F intersection to orthogonal F is subspace of E star. If characteristic of K is different to 2, then are equal. And we will use that subspace. R0 is an intersection between E star with orthogonal to E star. That subspace is totally isotropic. This, and for example, has equality. Well, in the case of la dimension of E to E star is finite, then we have that dimension are finite. And in this case, is orthogonal close, and because it's with the dimension, a finite dimension, and then R0 is orthogonal closest. That is, R0 is equal to B orthogonal of R0. How is dimension of orthogonal of E star is finite, then you can write in this form. And it's well known the metabolic decomposition of E as this type. We will return to that more
later.
Later, yes, later. Well, there are other objects. The Hermitian lattice. The Hermitian lattice is an algebra such that this is a modular lattice with the university bounds 0 and 1. And the operation orthogonal satisfies that not equation, but that. The idea is consider E star by B. In E star we have the radical is subspace of E star, and this is the relation given that. Well, the idea is the canonical example is given by an Hermitian lattice. Well, a canonical example of a Hermitian lattice given by sublattice subspace given by lattice of LE of a Hermitian space over key with a orthogonality relation given by form P. B is applied to space E star. I like to study that type of lattice and then introduce the definition of interfunction. That function is very good to study the irreducible fact to lattice. That relation is given to the relations has in quotient in two different spaces. For example, that say that dimension between k by x to I over y is you compare with when you take intersection with space theta, and you have this relation, or when you take a sum or when you take orthogonality between two spaces, and when you take a space between x and y, or when you take dimension is C. Well, this is an index function, the type of 0. And we use all of this definition to the work. The work asks consider an Hermitian space EC with finite codimension, that is, dimension between E over E star is finite, and consider two subspace totally isotropic subspace of E with U subspaces B. E I like to find the index Hermitian lattice associated with that Hermitian space. In the language of lattice, that L is generated by U and Y, B, totally is isotropic, and that these dimensions are finite. The that represent the dimension between I over I star. To study that lattice, you need in general simplified with different play. In this case, we consider you like to know what is L. But if you know that L is L1 product with L2, and you know like this, well, you try to know that, and because in general you didn't draw, because it's very complicated. For example, if you try to draw this one, I don't know, because I have it in 3 dimensions. I don't like. Is that it's possible to consider that? Well, you need relation, but the idea. And the idea is step to step to simplify the problem. Find that and then study that. Continue. But this with need this theorem given in the book of Gross. This theorem said if E is not degenerated, you have R to some space totally isotropic included in E and orthogonal closed, then there are that metabolic decomposition of E. That is a sum of hyperbolic plane and other subspace, where R is R is given by Ri. No.
Totally isotropic.
No, R is totally isotropic, and R known as generated by Ri. That's remember. Yeah. Remember the properties of E star. Well, this type radical is included in E star. R0 is totally isotropic. When this dimension is finite, that dimension is finite, then you can can use the theorem. We have R0 is totally isotropic, subspace of finite space, and then is orthogonal closure. Well, in this case, we have this. And you can write that. In this part, there are sum of hyperbolic plane and E0. And E0 is conformed to C such that orthogonal of E star is R0 plus C. You will use that in the first step. In the first step, we consider R0 is not trivial in orthogonal of E star. But above, we have that. And you look that. You write in this form. Well, you have B we have U less than B, B orthogonal, E star. Because B is not less than B orthogonal B, and then the intersection R is included in E star, and then B is included in E star, but C are included in E star orthogonal, and then C star contained to E star B orthogonal, and then contained to E star. Then you have that, and that, and B, E star are included in C orthogonal, and then B included in E1. Okay, have this in this part. Well, you can identify for, you have E has this component, but this type, and B is in this part, and then we will identify E1 with E and work with E1. When you use that, produce a first subdirective irreducible factor of lattice E. Is that the first? And then this is a first factor, and you work with the rest of E1, B in E1. Well, second step, by step 1, you consider orthogonal of E star included in E star. closed because it's finite, and totally isotropic by this relation. Then E have a metabolic decomposition. Well, if you consider R1 to be orthogonal of B, intersection to orthogonal of E star, you have one is finite, and then is orthogonal closed. If you suppose R1 is not trivial in orthogonal of E star, there exists D such that subspace is in this form. It's a finite, no problem. But using that and that, we obtain a second space, D star, D prime, such that orthogonal is B, you can write in this form. And then produce a metabolic decomposition of E with that subspace. And then you can prove that E star is D plus E2 star, and such that B is included in E2. And then you can identify E with E2. E continue. We obtain a second factor. Is that? Well, the idea is obtaining different irreducible factors of L. Well, now, by step 2, we suppose the orthogonal of E star is included in a B-orthogonal of E. Let R2 that space. We have it's finite, because that is finite, and then it's orthogonal rules. And we have R2, and that is totally isotropic. Then we have that metabolic decomposition of E. Now, suppose R2 is not trivial in that subspace. Then there you have this decomposition of B inter orthogonal to star. Using that, we have orthogonal to U. You can write in this form, and then you obtain that metabolic decomposition of E. In this case, you are in E3, B is D1 plus B intersection with E3, and E star is that. Well, in this case, we identify A with E3 and obtain the third factor. That is the third factor. And continue with the idea. Well, I suppose, remember in the book, the idea, you first to suppose that space is not trivial, and then you put in this form. Well, the next step is a trivial, and then we suppose that. Well, in this case, we suppose the intersection between B and orthogonal of E star is included in the orthogonal of U. Let D2, that's a space that is totally isotropic and finite, and then is totally isotropic and orthogonal closed. And in this case, you can discompose the metabolic decomposition of E of this form. Well, you can write U that D2.
Ana Cecilia, il tempo.
Second, yeah, okay. Well, the idea is continue with this process.
Yo dejaría esas decomposiciones y hablaría del reticulado.
Bueno.
Pero tienes 3 minutos.
Ya, ok, de acuerdo. Well, with this process we obtain different factor, and then we obtain L more simplified, and with that relation. That relation is given by first step, second step, etc. And we obtain L possess 68 element, and is that the different colors represent two different indices, and we have, for example, that indices are equal to that, or that are all equal and equal to that. That is B and the orthogonal. We have B and we have same indices in the.
This is just the diagram of page 41 of the actas with colors, and the colors concerns the subject directly reducible factors. So our prime quotients, all prime quotients that define the subdirectly reducible factor. Each color represents subdirectly reducible factor.
Furthermore, in the AXA, there are all the irreducible factors.
笑。